Hello, welcome to chemistry lesson today. We're going to start with a new chapter, chapter 7, rate of reaction. 7.1, determining rate of reaction. At the end of the lesson, you should be able to classify fast and slow reactions that occur in daily life, explain the meaning of the rate of reaction, identify changes which can be observed and measured during chemical reaction, determining the average rate of reaction and instantaneous rate of reaction, solve numerical problems based on the average and instantaneous rate of reaction. There are many reactions happen in our daily life. There are some examples here. Can you classify these reactions that occur in daily life into fast or slow reaction? For you to do this, you should be able to understand what is the meaning of fast or slow reaction. Fast reaction refers to any reaction that can happen in a very short duration, maybe several minutes or seconds. Whereas slow reaction take a longer time, maybe several days, weeks, or years for it to happen. If you refer to the process of food decay, here is a photo show the strawberry decaying. This is considered a slow reaction because it takes several days for it to happen. So as the rusting process and the photosynthesis process. So all these three processes are referred to slow reactions because it may take several days or hours or more than that to happen. Okay, whereas burning process, any burning process or the fireworks, these are the fast processes because it takes a very short duration, maybe several seconds or minutes for it to happen. The two types of reactions, such as fast reaction, for example, combustion, neutralization, precipitation, whereas slow reactions are, for example, food decay, rusting, or photosynthesis. What can you understand about the rate of reaction? The rate of reaction is the changes in the quantity of the reactant per unit time or the changes in the quantity of product per unit time. During reaction, the quantity of reactant used decreases, whereas the quantity of product formed increases. Rate of reactions can be measured by using the formula changes in the quantity of reactant per time taken for the change to occur, or changes in the quantity of product per time taken for the change to occur. There are units for measure rate of reaction. If involving mass, we're going to use the unit gram per second or gram per minute. If involving volume, we're going to use the unit such as centimeter cube per second or centimeter cube per minute. Whereas if involving the concentration, we're going to use the mole per decimeter cube per second or mole per decimeter cube per minute for measurement. There are suitable, measurable, visible changes in a chemical reaction. For example, volume of gas liberated, formation of precipitate, changes in the mass during reaction, changes in the electricity conductivity of the solution, changes in the concentration of the solution of reactant, color changes, temperature changes, pressure changes, or pH changes. Which is suitable for you to use? You have to depends on the reaction, and you have to observe which visible changes is suitable for you to measure. Here are some examples. First one involving formation of precipitate. This occurs in a reaction that produces insoluble salt. For example, silver chloride. Silver chloride can be produced by using two soluble salt solutions such as the sodium chloride and silver nitrate. So when you add these two soluble salt solutions together, you're going to get insoluble salt, which is a white color salt. This will going to cause a precipitate, cause the X marks to be disappear, and the amount of precipitate can be measured. The second one refers to mass of reactant decreases. This will occur in reaction that decrease in the mass of the reactant. For example, the reaction between calcium carbonate and nitric acid. This will going to cause the calcium nitrate, a soluble salt, carbon dioxide gas, and water being formed. So in this reaction, the mass of the reactant such as the calcium carbonate will decrease, and the loss in the mass can be measured by using electronic balance. The next one is referred to the volume of gas increases. Occurs in reaction that produce gases. For example, the reaction between magnesium and hydrochloric acid. So in this reaction, hydrogen gas is going to be produced. The gas release is collected and the volume is measured by using a gas syringe. Average rate of reaction. What can you understand about the average rate of reaction? The average rate for the reaction that occurs in a particular time interval. So this is referred to the average value for the rate of reaction that occurs in a particular time interval. That means within a certain duration. For example, the overall average rate of reaction can be measured by using total volume of gas collected per time taken. If you refer to figure 7.6, the overall average rate of reaction can be measured by using the volume of gas collected from the beginning until the time mentioned. So here you can use the volume V per time taken T, and the unit will be centimeter cube per second based on this graph, because the unit in use is centimeter cube and the time is second. The second one is referred to the average rate of reaction for the first second. So here you can use the total volume of gas collected in the first T1 seconds per time taken. If you refer to the figure 7.1, the average rate of reaction for the first T1 second, you can use the V1 subtract with 0 divided with T1 subtract with 0, because you start from 0 for the first T time mentioned, and the answer will be in the unit of centimeter cube per second based on this. The next one, refer to the average rate for T1 to T2. This one doesn't start from the beginning, but in a particular time intervals. So you can use the formula total volume of gas collected from T1 to T2 divided with the time taken. So here, if you refer to figure 7.8, the average rate of reaction from T1 to T2, T1 are labeled on the x-axis, such as the time, which is in the unit of second, whereas the volume of gas is in the y-axis. Here, the V2 and V1 already labeled. So for you to get the average rate for T1 to T2, you have to use V2 subtract with V1 divided with T2 subtract with T1, and in the unit of centimeter cube per second. Do remember to put in your units of measurement. What is the meaning of instantaneous rate of reaction? The rate of reaction at particular point of time, or actual rate of reaction that at that instant, is referred to the instantaneous rate of reaction. For example, if you refer to a sport event such as a short run, maybe 100 meters, you're going to find out that, especially towards to the end point, a student will speed up. So this is referred to the instantaneous rate of reaction. This means you can consider the rate at the end. Or you can refer to the speed trap, which the traffic police will going to trap those speed up at a certain time. So it is determined from the experimental data by plotting a graph of changes in the quantity of the reactants or products against time, and measuring the tangent gradient to the curve at that point of time. So this one, you have to always draw a tangent gradient, and you have to determine it. There are a few steps for you to do this. First one, you have to draw a tangent to the curve at the time mentioned, such as t. Let's say you like to get the instantaneous rate of reaction at, let's say the t is 3, the third second. So at the third second here, the theta You have to draw a straight line until you're touching the graph. And then at the point, okay, you have to draw a tangent. There are ways how can you draw a tangent, okay? So you can try to refer to your math teacher or you can refer to some informations. So use the tangent to complete a vertical angle triangle. So here is a vertical angle triangle being drawn. You have to try to draw the triangle that can be drawn in various sizes. The bigger the triangle, the most accurate it can be to determine the tangent gradient. So that's why try to do a bigger triangle. Next. Step 3. Calculate the gradient of the tangent to the curve. So here, after you draw the tangent, so you have to calculate the gradient by using the formula delta V per delta T. Delta V refer to the V2 subscribed with V1, whereas the delta T refer to the T2 subscribed with T1. Then you're going to get the instantaneous rate of reaction at the T second, and do remember put the unit centimeter cube per second here. Figure 7.10 refer to the instantaneous rate of reaction that involves the decreasing of reactance. So if the decrease in reactance, you're going to get a graph which is a curve downward. Okay, then the tangent will be drawn under the graph. It's time for you to exercise your mind. Try to do this question. Zinc and sulfuric acid reacts and form a salt and hydrogen gas. Calculate the average rate of reaction in centimeter cube per second if 30 cubic centimeter of hydrogen gas is released in 2 minutes. This is the answer. For you to get the average rate of reaction, you have to get the total volume of gas being released, such as 30 cubic centimeter per the time taken. Here, 2 minutes, you can change to the second by multiply with 60. There are 60 seconds in a minute. So that you're going to get the answer 0.25 cubic centimeter per second. Then it's time for you to do more practice because practice makes perfect. Okay, you can do these individual activities. First, can refer to the module given to you. Refer to the module, do your offline lesson study. Then please do the exercises given from your workbook and also from the module. You can get further information from the internet. There are a lot of information that you can get from here. That's all for today's lesson. Keep on studying. See you on next lesson.